Have you ever looked at the map of the world and wondered, wow, this looks like one giant puzzle, like you could just get the continents and push them together and they'd form some kind of supercontinent? Well, that's actually true. Around 225 million years ago, the supercontinent of the world was known as Pangaea. And Pangaea took up about 1/3 of the Earth with one surrounding ocean. But as these continents began to break into large, separate land masses, this was known as the continental drift. So how do these large masses of land actually move? Well, that's plate tectonics. To better understand the science behind plate movement, I'll be discussing satellites and sonars, temperature and convection flow, kinetic energy, and seismic waves. So why are satellites and sonar so important to plate tectonics? Well, this is how scientists know how the Earth is moving, when it's moving, and how much it's moved. They use GPS, or Global Positioning System. A GPS measures the rate of movement in north, east, and vertical directions. What is rate? It is the speed of motion. So imagine your mom is driving you to school because you're late at 65 miles per hour. Anytime you use a change in position with respect to time, you are using rate to do it. A GPS consists of a computer, an atomic clock, and a radio that detects and computes signals from space. A second method that scientists use is the satellite laser ranging. It is also satellites up in space, but these ones actually send pulses of light, and so it's a bit more accurate and more advanced in technology than the GPS, and they're becoming more popular than the GPS because they are more accurate. They can detect motion at smaller increments. So what is it that actually makes the continents move? Well, it's a combination of temperature and convection flow. The temperatures within the Earth can get super hot. We're talking 9,000 degrees Fahrenheit. The temperature is so hot within the core of the Earth and the pressure is so great that the particles within the center are actually a solid and not a liquid as you might think. The pressure is actually not letting the little particles in the center of the Earth move around. They're pushed on it so hard that the particles are only vibrating against each other and are solid. Convection flow is the circular motion in which the lava, I guess you can say, inside the Earth is moving. So imagine the hot lava moving from the center of the Earth where it's the most hot is going up towards the surface of the Earth, but underneath the crust is cooling off as it goes up. And then as it goes down, it warms back up because it's going down towards the center of the Earth again. Well, this is a continuous cycle and it just keeps occurring, keeps occurring. So as the material is moving down, that is the more dense material with less kinetic energy, and it gets warmed up when it gets close to the center, and then the kinetic energy gets higher because the particles are moving quicker and quicker, and it becomes lighter, and so it moves up towards the center of the surface. And again, the material actually cools down and becomes more dense, and the kinetic energy decreases. And then this is just happening over and over again. So as the convection flow is occurring, the continents or the plates are actually moving away from each other or together. But regardless, the plates are grinding against each other in such a way that they're building up friction. Because as these plates are moving together, the jagged edges cross each other and sometimes they get stuck. And then they stop and the pressure just builds and builds and builds. And when the pressure lets go, the energy is released abruptly. And that is the reason for plate movement. And so when the plates slip and break and release this energy, they cause two different types of seismic waves. The first would be primary, or P wave, and the second is secondary, or S wave. So the primary can pass through solid, liquid, and gas, and it is known as a transverse wave. Transverse means that the little particle is vibrating back and forth in a left-right motion. So it's going with the wave of energy. Secondary wave, or S wave, can only pass through solids, and the particle can actually only vibrate up and down, and that is known as a longitudinal wave. So from the supercontinent that existed almost 225 million years ago, known as Pangaea, to the seven big land masses or continents that we know of today, plate tectonics has always and will forevermore shape and reshape Earth as we know it. It is an ever-changing cycle of life and death.